day, everyone. I am Justin Marquez.
I am Renvic L. Sayson.
I am Cloe Diaz.
And I am Princess Gieren Delgado.
In this video, we'll be sharing on reflection and lessons we've acquired on our robotics class this semester. We engage in hands-on activities that introduce us to essential robotics components such as servo motors, ultrasonic sensors, and I2C LCDs, allowing us to better understand their function in real-world applications.
Servo motors are built to be super precise so they can move to exact angles and stay put when you send them signals. That's why they are perfect for tasks that tend to be spot on, stable, and move with control.
The servo motor is a bit different from the usual kind because it can move to specific angles and even stop to hold a position. While a regular DC motor, on the other hand, keeps spinning continuously as long as you give it power, without being able to control its exact position. When we started controlling the angles in robotics, it really shifted our perspective on movement. It's not just about how fast or in what direction something moves. It's also about how precise and controlled it is. Even tiny tweaks can make a system more accurate, but they can also lead to problems if they are not done right.
When we are working with servo motors, we run into some problems like wiring that was not quite right, codes that did not work, and angles that were off. But if we managed to get through it all by working together, double checking everything and teaming up to figure out what was going on.
An ultrasonic sensor uses some waves that we can hear. These waves bounce back, and the sensor measures how long it takes for them to return. This helps it to figure out the distance.
It handled flat surfaces like walls well. Occasionally, the measurement might not be accurate if the object moves quickly or is small. We figure out also how to stop the ultrasonic sensor from working by moving it closer to the wall. The sensor's angle to the object and noisy areas with a lot of people talking or other electronics running also played a role, causing the readings to fluctuate a bit.
These systems could determine distance and gradually decelerate, making the project effortless to use without an interaction, as it autonomously detected object.
LCD displays sensors readings such as distance and values, and system status page help show what was detected and doing in real time.
I2C simplified wiring by using only two communication pins instead of multiple data pins. This made the circuit cleaner and easier to connect. Feedback is important because it allows users to monitor the performance and understand its behavior. It helps confirm if the system is working correctly.
The LCD help by showing live data and system message, making it easier to identify errors and mistakes during the operation of demonstrations.
Each component had a specific function, but they depended on one another to work as a complete system. The sensor collected information, the controller processed it, and the actuator and display responded based on the information.
For example, in Activity 4, we created an interactive button and LCD I2C system using Arduino. We learned about input detection, conditional programming, and how to update displays in real time in an automated system. When the push button on the breadboard is pressed, it sends a signal to the Arduino by changing the voltage on the input pin. The Arduino detects the press displays button pressed on the LCD I2C, pauses briefly, clears the screen, and then continues monitoring the button. This activity showed that automation works when hardware and software cooperate through proper programming to perform tasks automatically without constant human control.
The challenging part of what we did before was figuring out what was wrong with each task. It could be anything from coding glitches to problems with the wiring and pieces of the robotics setup.
In Activity 1, Servo Motor Position Control, the servo motor was supposed to rotate a specific angle with a 1-second delay, but it did not move at first. After troubleshooting, we discovered that some wires were connected incorrectly. Once we fixed the wiring, the servo motor worked properly and responded to the code. These challenges and difficulties really help us develop the skills we pick up in each activity, like patience and teamwork. They also pushed us to test our problem-solving skills and keep going even when things got tough. The most valuable skills we learned is using Arduino to connect sensors, actuators, and displays and make them work together through coding and wiring. This will be a great asset for us down the journey, especially when tackling tech-related tasks and engineering projects. We imagine a smart trash can that uses an ultrasonic sensor to detect a hand and automatically open the lid with a servo motor. An LCD I2C shows reminders to keep the area clean. These components show how technology can help solve real-world problems. By improving and using systems like this, communities can benefit from smarter and more efficient solutions that promote cleanliness, safety, and environmental care.
Yes, we still want to learn and expand our knowledge about robotics because for the coming generations, it is better if you all know and have an idea about these things because as time goes by, technology is expanding more and more. We suggest that you take a moment to double check each sensor before using it. It's always a good idea to go through the steps carefully so you can complete the task successfully.
We learned that in robotics, teamwork and creativity are just as technical skills. As we move forward, let's keep experimenting, learning, and pushing the limits of our creativity and skills to achieve the goals we want to achieve. The future of robotics in our hands. Keep building and achieving.